Okay, so this is going to be a video about the changing phases between solid, liquids, and gases. Okay, so recall that atoms are in constant motion. Even with solids, there's still motion. It's just not as great as it is in a liquid or in a solid, right? And increasing thermal energy or heat by adding heat causes the atoms to vibrate faster, and decreasing thermal energy or allowing a substance to cool down causes atoms to vibrate slower, right? And temperature itself is actually a measurement of the motion of the particles. So when we're measuring something's temperature, we're actually measuring the motion of the particles. Okay, now within substances, chemical bonds hold atoms together. However, there are different types of chemical bonds, some that are stronger than others. For instance, this is an atomic bond, which we'll learn more about in chemistry, but that's when two ions are bonded together. Within a water molecule, the bonds that form between the hydrogen atoms, the two hydrogen atoms, and the oxygen atom are called covalent bonds. These are also very strong chemical bonds, and they hold the actual water molecule together. Right now, another type of bond is called a hydrogen bond, and these are weak bonds. These form between two or more different water molecules, between the hydrogen of one water molecule and the oxygen of another water molecule. Okay. Again, these are weak bonds. These are the ones that are affected during phase changes. These strong bonds within the molecules are not affected. When we, boil water into steam, it's still going to remain as a water molecule. It's just going to change states. It's just a physical change. If we were to do a chemical change to water, then it would not be water anymore. But this is just a physical change. It's still going to be water. It's just going to change states. And the only thing that's being affected are these hydrogen bonds between different water molecules. Okay, so what happens when a substance is changing state, such as water? Okay, so when thermal energy or heat is added, the molecules begin to vibrate faster. Right, and those vibrations will cause the weak hydrogen bonds to break, but the covalent bonds, they won't break. So the water molecules still always remain intact during phase changes. Okay, so when heat is added to ice, all right, so here's water in the ice form, in a solid form. And remember, the molecules are not vibrating that fast, and the bonds hold them very strongly in a crystallized structure. Okay, so once you add heat, these water molecules begin vibrating faster, and these hydrogen bonds begin to break, right? And when the temperature reaches the melting point, the water the water, the hydrogen bonds break, and the water molecules are then able to slide past each other. And that's when water begins to flow, when when the solid turns into a liquid and becomes water in a liquid form. All right, now when heat is removed from a solid, from a liquid, and the liquid's allowed to cool down, then the atoms begin to slow down, and the hydrogen bonds can form again between the different water molecules. And so then the water molecules begin to solidify into the solid state or to form ice, and we call that freezing. All right, so as hydrogen bonds form, the liquid freezes into a solid. Okay, now the melting and freezing point, the temperature at which this happens for any substance occurs at the same temperature. Okay, so for water, water freezes and melts at 0 degrees Celsius. So that's the freezing point of water, or the melting point of water. Okay, the only thing that differs between melting and freezing is whether you're adding heat or whether you're removing heat, but it's going to occur at the same temperature. Okay, now most substances have their own unique melting point. If you notice here's some gases, oxygen and nitrogen. they have a very low melting point. So they're already been in liquid form long before you get to 100 degrees Celsius. In fact, they're already boiled into a gas by the time you get to 0 degrees Celsius, right? For metals, they have higher melting points, and so often they'll be solids at room temperature. So now room temperature is about 20 degrees Celsius. So substances with melting points higher than 20 degrees Celsius will be solids at room temperature. For example, sulfur is a solid at room temperature. It melts at 112 degrees Celsius. So you could take some sulfur and boil it and melt it, whatever, and it will become a liquid at that point. It wouldn't take too much. You could do that on a stove. All right, substances with melting points lower than 20 degrees Celsius, lower than room temperature, they'll be liquids or gases at room temperature, like mercury. Mercury is the only metal that's a liquid at room temperature, right? Its melting point is negative 39 degrees Celsius, right? So at room temperature, it's already melted into a liquid. And that makes it a pretty cool element. We'll watch some videos of people playing with mercury later. Okay, now one characteristic of metals is that they have higher melting points, and so are mostly solids at room temperature, other than mercury. That's the one exception. These are all solids. So here it's represented by like an ice cube, that these are all solids at room temperature. Tin, zinc, silver, copper, chromium, aluminum, gold, lead, iron, right? And you can see that the nonmetals are either liquids or gases at room temperature. All right, now when we're going from a liquid to a gas, right, when heat is added to water, so here are the water molecules, and the bonds are not completely broken. They're just broken enough so that the water molecules can slide past each other. Okay, but when you add heat, the molecules begin vibrating even faster to completely break free. And when they completely break free, they turn into a gas, right? And so water turns into steam. Okay, and you do that by increasing the temperature. And that happens at the boiling point, right? That's when liquid will turn into a gas at the boiling point, right? And for water, we call that gas steam. Right now, when heat is removed or the gas is allowed to cool down, then the molecules begin vibrating slower and the temperature decreases. And that allows the bonds to begin forming again. And so the gas will turn into a liquid, right? And that happens at what's called the condensation point, right? And as the hydrogen bonds form, the steam condensates into water. Okay, now once again, the condensation point and the boiling point, they occur at the same temperature. The only difference that's going to happen is that if you're adding heat, the liquid will turn into a gas. If you're removing heat and allowing it to cool down, then the gas will turn into a liquid, right? And so here you can see a glass with water condensating on the outside of it. That condensation comes from water vapor in the air being cooled down by the cold glass of water. Right? It's not coming from the inside the cup or anything. It's coming from the water vapor in the air. All right. Okay, now, most substances have their own unique boiling point or condensation point. Right. So here you can see that the gases, that the nonmetals, helium, nitrogen, chlorine, hydrogen, oxygen, they have very low boiling points. Right. So they're lower than room temperature. Look here, room temperature is 20 degrees Celsius. So substances with boiling points above room temperature, they're going to be liquids or solids at room temperature. They haven't reached a temperature at which they'll boil into a gas. All right, substances with boiling points below 20 degrees Celsius will be gases at room temperature. All right, so oxygen, and here's liquid oxygen. It's a very pretty blue color. Oxygen turns into a gas at negative 183 degrees Celsius. Right? We often use liquid oxygen for things. They in the NASA spaceships, when they travel up into space, it's easier for them to carry it in the liquid form, and that's what they carry it in. All right. Okay. So again, most nonmetals will have lower boiling points, and so they're usually gases at room temperature. And then, of course, your metals are going to have higher boiling points, so they're going to be solids or liquids at room temperature. Okay, so for the I can statements, I can explain what happens to the bonds between the molecules when heat is added to a solid. Right? So remember, when we add heat, the molecules begin vibrating faster, and that begins to break the bonds so that the molecules can slide past each other and it turns into a liquid. Right? So explain what happens to the bonds. The bonds begin to break when you add heat to a solid, and it causes a solid to turn into a liquid. I can explain what happens to the bonds between the molecules when heat is removed from a liquid. Right? So when we allow a liquid to cool down or remove the heat, the molecules slow down and the bonds begin to form. So a liquid turns into a solid. I can explain what happens to the bonds between the molecules when heat is added to a liquid. Okay, so once again, when we're adding heat, the molecules will begin vibrating faster and the bonds will break, completely free from a liquid to turn into a gas. All right, I can explain what happens to the bonds between the molecules when heat is removed from a gas. Right, so when we allow a gas to cool down or remove the heat, the molecules will vibrate slower, and then bonds can begin to form, and that will cause the gas to turn into a liquid. Okay, so that's the end. I hope that explains that.